This lecture is about basic probability. We will be talking about concepts of sample spaces and events. We'll begin with some basic terms here. The first of this is the sample space. The sample space is the set of all possible outcomes. And an event is a subset of the sample space. So when we look at this in terms of the Venn diagram, the sample space is everything that could possibly happen, and an event is just a collection of some of the things that happen. Typically we will denote the sample space by X, and a particular event we'll denote by the letter capital E. We'll let capital N denote the total number of outcomes in the whole sample space X. So recall previously we have used capital N as the number of things in our population. Well, this is like that. Okay, we're going to let little e be the number of outcomes in an event E, and we'll let P of E denote the probability of the event E. Now here this formula is going to work for equally likely outcomes, and so the probability of our event E is little e divided by capital N. Okay, and so you should notice here that since little e is always going to be littler than capital N, at most it'll be equal to N, that the probability of E is always going to be between 0 and 1. Okay, so let's look at some data here. Here I have again data. It looks like the scores from an exam. Okay, and I took the mean of these scores. I got 75.78, and you're right, I should have rounded this off to 75.8, but we're being a little sloppy here. The standard deviation is 11.43, and we should have rounded this off to 11.4, being a little sloppy since I'm having a spreadsheet do it. Now I took the mean and I took the standard deviation, and I used that to take the z-score of my data. So this right here, right, this data is just this data after we've taken the z-score. I then broke down into a relative frequency table here, right, counting the things which have standardized between -3 and -2. There were 2 of those out of the 50 total scores, and 2 divided by 50 is 0.04. So I had like 4% of my data had standardized score between -2 and -3. 6% was between -1 and -2, and so forth. Okay, in this way, again, all I'm doing here for this, I'm counting the number of data items up here that fit these particular classes, rolling them into the frequency column, and then dividing it by the number of numbers to get the relative frequency. Okay? So I can take this, okay, and put this in terms of probability. Okay, see my z-score, little z. Okay, the probability that little z was between -3 and -2, that was 0.04. The probability that little z is between -1 and -2 is 0.06. The probability that little z is between 0 and -1 is 0.36. The probability that little z is between 0 and +1 is 0.42. The probability little z is between 1 and 2 is 0.06. And the probability that z is between 2 and 3 is again 0.06. Okay. So again, we can view these data as in terms of probability with equally likely outcomes. Okay. I want to talk now about the definitions, simple set theory, unions and intersections. A union B is the set that concludes every element of A and every element from B. A intersection B is the set that contains elements that A and B have in common. If we represent this by Venn diagrams, A union B is my set A glommed together with my set B. And if I take A intersect B, it's again this overlap that they have in common between the set A and the set B. Now I set up some notation here. Little x is going to be the number of elements that these sets have in common. A is going to be the number of elements in the yellow set A. Little b is the number of elements in the blue set B. Okay. So yeah, again, I have it written out here, and so okay, I calculate the probability of A union B. Well, that'll be the total number of things in A and B union together. Now, if we add A, you'd think at first that if we added A and B together, then that would be it, but you would be discounting, you'd be forgetting about, you count the stuff in the overlap twice, so you have to take it out. I can then do some algebra to this, break this fraction out into A over n plus B over n minus little x over n, and calculate the probabilities and get this pretty little formula down at the bottom. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay. Now we want to talk about the complement of an event. Okay, if this is an event E, the complement is just everything that's left over. It's like you take a cookie cutter and cut this part out. What's left over is the complement. Okay, and so the probability of X is the probability of E union the complement, because you take E, you take its complement, right? You take the cookie and put it back in the hole. You get the whole original piece of dough you had, right? So I can take this and I can apply that formula I just derived to it. Probability of E plus the probability of E complement minus the probability of E intersection E complement. But E intersection E complement is empty and it has a 0 probability. Okay. And on the other hand, the probability of X is equal to 1. So I can say the probability of E plus the probability of E complement is equal to 1. I can do some algebra to rearrange this and say the probability of E complement is 1 minus the probability of E.